Hello, welcome to today's geography lesson. Today we're going to discuss synoptic charts and global air circulation. Now, I bet many of you is already familiar with both these terms because we discussed them in grade 10 and in grade 11. Now, the global air circulation, we're just going to revise from the grade 11 syllabus, and synoptic charts we did in grade 10 and 11. Now, basically by now you should know a synoptic chart is basically like a weather map. The first thing that you learned in grade 10 about climatology was the difference between weather and climate. Now, obviously by now you should know climate takes place over a period of 20 years and weather happens on a daily basis. Now, with the synoptic charts, there's key things to remember. What I like about synoptic charts, all the answers are usually right in front of you. Now, if we go to our first slide, we will see that when you look at synoptic charts, if you can revise from grade 10 and grade 11, you will see that synoptic charts is full of these lines. These lines are known as isobars. Now, these lines represent pressure. Now, exactly the same what you've learned in grade 10 and 11 regarding map work, isobars is lines joining places with equal pressure. For instance, in map work, you've learned that the lines joining places with equal height on a map. Now, basically, we're going to look at two things that's very important on a synoptic charts, the type of pressure systems that we find on them. Now, pressure is measured in millibars and hectopascals. Now, the two pressures that I want to discuss with you today is patterns that form over them. And the first one I want to discuss is a low pressure. Now, very importantly, if you look at the low pressure, it's decreasing towards the inside of these isobars. Now, if you look at the characteristics of a low pressure system, it's associated with rising air. Now, grade 12's, what's quite important over here, when air rises, we associate it with warm conditions. Now, if I can give you an example, let's say for instance boiling water. You boil water, what does it do? It evaporates, it rises. Now, same principle happens with air. As soon as it's hot, the air starts to rise. Another example how the air can rise is when it's forced to rise. Now, very importantly over here, we're going to see it as we continue with the grade 12 syllabus. It usually happens when warm air and cold air converges. Now, by now, hopefully you know that cold air is much heavier than warm air. So what does it do? It forces the warm air to rise. Very importantly, if you can go back to our previous diagram, the circulation of a low pressure cell in the southern hemisphere is clockwise circulation. Now, just to keep in mind, if I can quickly draw a globe over here, we are situated in the southern hemisphere, and these low pressure systems will turn clockwise. Now, keep in mind, once again, characteristics of these low pressure systems is usually warm air. Now, the warm air rises. It's usually, the air can rise because it's being forced to rise, and very importantly, in the southern hemisphere, it's a clockwise circulation of air taking place. So, obviously, in air circulation in a low pressure system in the southern hemisphere is clockwise circulation. Now, very importantly, it's vice versa in the northern hemisphere, and the air circulation is anti-clockwise. Now, when we look at the low pressure systems, I want you to remember, it's usually rising air. What do we associate rising air with? Warm conditions, or usually when the air is being forced to rise. Now, let's just quickly look at high pressure systems. A high pressure system is usually associated with cold conditions. It's usually when air sinks. Now, I'm going to use a blue color pen over here to show you the circulation in the southern hemisphere. In the southern hemisphere, it's going to be an anti-clockwise circulation of air. Now, high pressure systems are usually associated with cool temperatures that usually sink. Now, just imagine this. Let's say, for instance, you jump into a swimming pool. Where do you find the coldest water? On the bottom of the swimming pool, on the surface of it. And the warmer water will be on top of it. That's exactly the same way how air works. Now, if we look at the characteristics of a high pressure system, we know it's cold conditions, usually, and the air sinks. And if you look at the air circulation of high pressure systems in the southern hemisphere, it's usually anti-clockwise. And in the northern hemisphere, it's usually a clockwise circulation. The 3 points that I really want to concentrate on today is the following 3. So, when we look at the 3 points that I want to highlight today, it's basically that you need to know that high pressure is usually sinking air, that the air sinks because of cold conditions, and it's an anti-clockwise circulation of air in the southern hemisphere. Now, very importantly, when we discuss synoptic charts, like I've mentioned before, there's many lines that represent the pressure, and they are known as isobars. Now, every single day, a synoptic chart's been printed by the South Africa Weather Service. Now, to indicate the weather, like I've mentioned before, weather happens on a daily basis. We use weather station models. Now, I bet you guys are definitely familiar with it. When we look at a weather station model, it's a small model looking like this. And it's got a set of information that help us to describe the weather of the current day. For instance, the air temperature is 27 degrees Celsius. The dew point temperature that we experience is 24 degrees. Now, very important, grade 12s. Some of you make the mistake to see the dew point temperature as the minimum temperature. Keep in mind, dew point temperature is where condensation takes place. Now, what is condensation? It's when the gas, the water that's been evaporated, turns back into a liquid. Now, precipitation is any form of water that falls to the surface. In this case, we experience rain. Then the body of the weather station is this circle over here. That represents the cloud cover. Now, you've learned in grade 10, how do we measure cloud cover? By using our eyes. In this case over here, you can see that the whole circle has been colored in, so that means it's overcast conditions. And when we look at the wind speed and wind direction, as you can see, it's attached to the body of the cloud cover over there. That gives us a northwest direction. How do I know that? Because if you look at your weather station model, this is where north is. There's east, there's south, and there's west, as you can see in the northwest direction. The wind speeds that's been allocated over there is 15 knots. Now let's just quickly move down to each key that we actually use. As you can see, the cloud cover is being expressed in quarters. Now, obviously, if you can see the circle over here, a clear circle means it's clear conditions. There's no clouds whatsoever in the sky. If you look at this one over here, 3/4, it means it's cloudy, right? And overcast conditions, when it's usually raining, there's a lot of clouds in the sky. The wind speed are measured in knots. 5 knots, very importantly, been drawn like this. 10 knots, like that, and 15 knots, a long and a short one attached to the direction of the wind. Now, the precipitation that we can discuss is as follows. You get rain, drizzle, showers, snow, hail, fog, and mist. Now, obviously, in the interior of South Africa, we experience thunderstorms, most likely over here. In high areas like the Gr12 Mountains, we experience that. Okay, so this is quite key. Now, very important that you need to remember grade 12s. when we ask to discuss the type of weather that's being experienced, let's say in Johannesburg for the specific day, you need to use these elements to describe the weather. So if the question in the exam states, describe the weather that Johannesburg is experiencing today, you need to refer to it as following. We're experiencing an air temperature of 27 degrees Celsius, a dew point temperature of 24 degrees Celsius. We might experience rain, we're experiencing rain, cloud cover is overcast, we're experiencing a northwest direction wind, and it blows 15 knots. Now that's what's making Synoptic Charts so much fun. That information is on the Synoptic Chart. All you need to do is describe it from the Synoptic Chart. So you don't need to go and look for the answer, it's right in front of you. Now, very importantly, like I've mentioned, to describe the current conditions, this is what you use. Now, in the exam, you're going to be asked a summer synoptic chart or a winter synoptic chart. The easiest way to go and look between the difference between a summer synoptic chart and a winter synoptic chart straight away is the date. Now, obviously, you know we live in the southern hemisphere. When do we experience summer? November, December, January. When do we experience winter? Usually during June, July. So that's the first thing I will go and have a look at, just to identify which season this synoptic chart is in. And then there's a couple of characteristics that you need to pay attention when you're looking at this summer synoptic chart or winter synoptic chart. For instance, over here, I have a summer synoptic chart. And now, the most important thing over here, have a look at the date. It's the 24th of January 2011. So that's a straight giveaway. Immediately you know it's summer. The second thing that you need to be able to identify is this low pressure system over here. Now, a couple of slides back, we discussed the different type of pressure systems. And we discussed the low pressure system. And what's the first characteristic that we discussed about it? It's rising air. And why is the air rising? Because of warm conditions. And when do we experience warm conditions? Usually during the summer. Now keep in mind, what's the circulation of air in the low pressure system? Clockwise circulation. Another tip to give you, that's a straight giveaway. Look at the air temperatures of your weather station models. Look at this city of Zimbabwe, Bulawayo, a maximum temperature of 20 degrees. Unfortunately, our synoptic chart is a bit unclear over here, but if we look at the Limpopo province, you can see that the maximum temperature over there is 28 degrees Celsius. Now, later during the programs, we're going to learn about tropical cyclones. Now, tropical cyclones is low pressure systems that develop in tropical regions. It only develops in tropical regions that experience high temperatures. And as you can see, there's a tropical cyclone over there, and that's another indication that it's in summer. Very importantly as well, South Africa is dominated by a high pressure belt. That's situated right over here. And you will see that the South Atlantic high pressure system has migrated to the north. And the South Indian high pressure system has migrated northeast. And very importantly, when we go into our next slide, the Kalahari high pressure system is not present in the summer because of weak subsidence and warm temperatures. Please stay with us. We're just quickly going for a quick break.